All right, so welcome to everybody. We are taking a look at Chapter 6 of the Hurley book today, dealing with propositional logic. And at Section 6.1, it talks about the symbols and propositions. Basically, this is the way we're going to translate our ordinary language into this symbolic form, because propositional logic is the first of our symbolic forms of logic. Whereas Aristotle's categorical logic was very much grounded in language itself, this one starts to look a little bit more mathematical. Don't let that scare you, it still makes sense, but it does look a little bit more mathematical. Well, basically, in propositional logic, the first thing that we're going to be concerned with is what's called a simple sentence. A simple sentence is a statement that is being made. So it's a statement, it still makes an assertion, it still has a truth value, but it's claiming one entity, it's claiming one thing. Hence a simple statement. And it's always a positive thing. So for example, the door is open. That would be an example of a simple sentence. The door is open. It's talking about one thing, it's making a positive claim. The lights are on would be another example of that. So these are the basic units that we're dealing with, are the simple sentence. Now within propositional logic, each simple sentence is going to be given a sentence letter. Okay. Now remember how in categorical logic you had the four specific vowels A, E, I, and O, which stood for different types of statements. Well, here it's not so rigid. Here it is purely arbitrary what letter you use to stand for the simple sentence. It's just a question of making sure that you know what that letter stands for. Typically what we do is to use the first letter of your subject. So for example, the door is open. I would assign that sentence letter D to stand for it. The lights are on, lights, I would assign that sentence letter L for that purpose. And of course, you can use A's and B's if you want to, or whatever, as long as you know what it stands for. It is arbitrary, but this is kind of the typical way of doing it. The exception to that rule would be if you were dealing with two statements that had the same letter, then obviously you would have to come up with something different for the second one. You can't have two sentences standing for the same letter, or two letter, it's not going to work that way. So that's the first thing that we need to do, is the simple sentence. But of course, a lot of times in logic, we're not going to be concerned just with a simple sentence. We are going to want to perhaps negate those sentences, or maybe make more complex or compound statements for us to have to deal with. Well, if that's the case, then we're going to need to learn 5 basic relationships and the symbols associated with them. Okay. And so let's start very simply with the idea of negation. Okay. Negation is when you want to deny a claim. You want to say something is not the case. Well, the symbol that's used is called a tilde. And it's like a little squiggly line like this that is put in front of the letter, and that negates it. So, for example, we say the door is open, and we said that's D. Well, if I wanted to say the door is not open, if I wanted to deny that claim, I would simply put tilde D. Okay? It is not the case that the door is open, so I'm denying it. Or the lights are on is L. So if I wanted to say the lights are not on, I just put the tilde in front of it, tilde L. It is not the case that the lights are on or the lights are not on. So negation is very easy in that respect. It's simply a matter of putting that tilde in front of the sentence letter to negate the simple sentence. The tilde is the only one that can work on its own like this. Any other symbol that we're going to look at is going to be used for joining two letters together. Okay. But the negation can be, in front of a single letter like that. So that's the first symbol you need, is the negation or the tilde. The second thing, or the second relation that we want to look at, is called a conjunction. A conjunction is when you want to join two or more sentences together with words like and, but, yet, things like that. Actually, in your book, it'll list a whole column of different words that can be used for that, as a conjunction. But for our purposes, really, and, but, and yet are the major ones that we see. The conjunction, the symbol that's used, and I'm actually going to be giving you two symbols as we go on for some of these. The reason being that the book uses one set of symbols, but the computer is not actually able to make some of those symbols. And so what I've had to do is to use an alternative system of symbols. So I'm going to give you both of them right from the start here, and of course I'll remind you of that on the blackboard as well. But the symbol that the book gives for a conjunction is just a dot. Okay, just a little simple dot. And so that dot would come between two sentence letters. So for example, if I wanted to say the door is open and the lights are on, I would just say D for door is open, the dot is and, L for lights are on. And it's simple as that. The door is open and the lights are on. The other symbol, the one that, because this dot being placed up like that, I could make a period, but putting it up like that, it's not on the computer. So we're going to use the ampersand because the computer can make that symbol. So when you go to do the exam, you're going to want to look for the ampersand for conjunction, which is D ampersand L. Again, the same basic idea. D, the door is open, and L, the lights are on, D and L. For your own purposes, you can use whichever ones of these you prefer. It's probably a good idea just to get accustomed to using the one that's going to be on the computer, but either way, it's fine. They're both accepted forms. They're depending upon which logic book you get, which system you're using, there are different symbols that are being put into place. So both of these are accepted as symbols for conjunction. So that's the conjunction, joining things by and, but, or yet. The next relation we have is called the disjunction. Disjunction is basically an either-or sentence, one or the other. And the symbol that's used for that is called a wedge. It's just basically a little lowercase v. So we know that the computer is capable of making that. Again, that wedge will always go between two letters. So if I wanted to say either the door is open or the lights are on, I'd have D wedge L. Right? Either first part, the door is open, or second part, the lights are on. Okay? So for the most part, this idea of translation here is pretty simple. It's pretty straightforward. Also, I think it's worth mentioning too that with the disjunction, with the conjunction, the ordering doesn't really matter. I mean, D or L is really the same as L or D. It's not going to change anything. It's basically saying one or the other. Or if it was with the ampersand, again, it's one and the other, regardless of which way. Where the order does matter is going to be with the fourth symbol that we look at. It's the one that always gives us trouble, and that's the conditional. A conditional, as you know, is an if-then statement. Now here again, we're going to have two different symbols. Your book uses the symbol of a horseshoe, which looks like that. And again, it would be between two letters. Now here, as always with the conditional, the order is going to matter. The order does matter. The if part, your antecedent, is always before the horseshoe. The then part, the consequent, is always after the horseshoe. Okay, so antecedent, horseshoe, consequent. The horseshoe is not a symbol that the computer has. Therefore, I have to use the other recognized symbol for this, which is the arrow, which looks like that. The arrow can be made by dash dash right-facing caret. But anyway, that's the symbol for the arrow. But it's the same basic thing. So the antecedent before the arrow, the consequent after it. So if I wanted to say, if the door is open, then the lights are on. If the door is open, D, then the lights are on, L. Okay, so D arrow L or D horseshoe L, whichever one you choose to use. So that symbol is going to work for the conditional. Keep in mind, again, what we learned in the last chapter, which is the conditionals are not always written in that strict standard form. So if I have, for example, A if B, remember you've got if, what follows if is the antecedent. So this is basically saying if B then A, which would be B horseshoe or arrow A. But also you might have A only if B. And again, as we learned in the last chapter, when you have only if, what follows only if is the consequent. So this is basically saying if A then B, which would be written A arrow or horseshoe B. Okay, so remember that difference between the if, which leads you to the antecedent, and only if, which leads you to the consequent. That's the hardest part of all of this, is just remembering that. Okay, so that's the conditional, again, the arrow or the horseshoe for that. We have one last symbol, one last relation that's talked about here, and that is what we call a biconditional. And a biconditional is a conditional statement that works both directions. Okay, so whereas the basic conditional only works from antecedent to consequent, the biconditional actually works both directions from the antecedent to the consequent, and vice versa. And this one, what you're looking for are the words if and only if. Okay? If and only if. So notice what's happening here, right? If leads you to the antecedent, only if leads you to the consequent. And so it's telling you both of those are the case. The symbol that gets used for this is in the book a triple bar, just like that. Okay, 3 bars. And so if I wanted to say the door is open if and only if the lights are on, it would be D triple bar L. Okay. For the purposes of the computer, again, you don't see a 3 bar anywhere on there, so I use just a double bar for that, which actually makes sense because when we start talking about truth values in a little bit, you'll see that sure enough, if and only if, you are looking at an equality aspect. You're looking for both of these to have the same truth value. So it actually kind of makes sense to be an equal sign rather than the triple bar. But anyway, for the work on the computer that I give you for the exams and whatnot, you'll see the equal sign for the biconditional. And again, I'll give you all of that information on the screen so that you're able to be reminded of the different symbols. But in the book, it'll be a triple bar. Okay? So that's if and only if. Basically, this is the same as saying if D, then L, and if L, then D. Okay, a conditional that goes both directions. It's just a shorter, easier way of doing it. All right. So those are the basic symbols that we'll use along with the sentence letters to translate in propositional logic. Okay. So now that we've seen the basic symbols and we've seen the sentence letter idea, there's one other thing we need to talk about, and this is what's called punctuation. Just as in logic, or just as in language rather, you need punctuation for your statements to make sense, you also need punctuation in logic. And there are three different systems or three different types of punctuation that we use. The first one is a parenthesis. That's the most common, that's the one you're going to be dealing with the most. We also have brackets, and finally, and very seldom used, braces. Okay. So those are the three forms of punctuation that are used in propositional logic: parentheses, brackets, and braces. When we start working with figuring truth values and determining validity and all that, the thing to remember too is that just like in mathematics, you have an order of operations. You also have an order of operations in logic, and this is that order. You do what's in the parentheses first, then what's in the brackets if you have them, then what's in the braces. So where would we use something like this? Well, suppose that we have that sentence we had before, the door is open and the lights are on. Okay. Well, if I want to deny that whole statement, it is not the case that the door is open and the lights are on. How would I do that? Well, if I simply put a tilde in front of the D, then that tilde would only range over the D. It basically would say that it's not the case that the door is open, but the lights are still on. I don't want that. I want to deny the entire value of the statement, and so the parentheses being around that tell me that the tilde ranges over all of this. It's denying the total value of all of this. So it is not the case that the door is open and the lights are on, right? So the whole concept. So that's one way in which you might use parentheses, would be to deny a longer statement like that. Another instance where it might be necessary would be to maybe you're joining three things together. Right, so we've got the door is open, that was D, the lights are on, that is L, and the window is open, let's make that W. So I want to say if the lights are on, then either the window is up or the door is open. So if the lights are on, then either the window is up or the door is open. Okay. So you see there are three things being involved here. The lights are on, the window is up, the door is open. But if I simply put symbols between them and said L, horseshoe, W, wedge, D, that's going to produce a real problem for us because we don't know what our main operator, our main connector is. And so we have to go back and figure out where would we put parentheses to show what hangs together. And it's just a matter of reading the English language and remembering how grammar works. If I see if, the next thing I want to look for is then. Everything between the if and the then is the antecedent. Everything after the then is the consequent. So the antecedent is just the lights are on. There it is. The consequent is this disjunctive statement, either the windows are up or the door is open. So that shows me that the parentheses would go around the W wedge D to show that it hangs together as the consequent of the conditional statement. Okay, so that's another area where the parentheses would be necessary, would be in terms of working with 3 or more statements. Now, what about brackets? Well, again, just like I showed you before, suppose that I wanted to deny part, that I wanted to deny not part of this, but all of this. So it is not the case that. Right? It is not the case that if the lights are on, then either the window is up or the door is open. Well, again, if I want to deny it, I'm going to use the tilde. But if I just put the tilde there in front of it by itself, then that tilde is only going to deny the statement about the lights. Basically, this would say, if the lights are not on, then either the window is up or the door is open. And that's not what we wanted it to say. So, since we already have parentheses here, you're not going to have a double set of parentheses, so that's where you go on and use your second punctuation, which would be the brackets. So now that tilde ranges over the whole value again, so it is not the case that if the lights are on, then either the window is up or the door is open. Okay. So that's the basic idea as far as brackets are concerned. Now, for your own purposes with translation here, parentheses are primarily what you're going to use. You might see a bracket once. Braces, pretty rare. There's very seldom any real reason for them. But, you know, suppose you have I'll give you a random looking thing here. All right. So let's say when I don't know, because when you get into statements that need braces, they're so big and obnoxious that I can't even think of ones that would actually really exist in the world. So I don't know what A, B, C, and D stand for here really. But let's suppose that you've got something like this. You can see that you've got if A and B, then C or D, if and only if B or D. All right, so we've got a big long equation here. Suppose I wanted to deny all of that. Well, again, we've used the parentheses, we've used the brackets. Well, then we'd have to put in the braces like that with the tilde on the outside, and that would give it, you know, our ability to deny whatever this obnoxious statement actually says. All right. So that's the basic idea there as far as the translations go. Now, as you go through the text, you'll see around page 317, you've got your 5 operators, what they stand for, keywords to look for. As you go through 6.1, you'll see a number of different examples that can kind of help you to clarify how to do various translations. The last thing I wanted to talk about in this particular section, right around page 323, you'll see where it's talking about the negation aspect. One of the things to remember when you're dealing with negation. You want to know, are you going to deny the entire statement? Are you going to deny part of the statement and not the other part? And it's simply a matter of looking at where the negation is. If the negation is before the subject, then you are denying the whole claim. If the negation is after it, then you are denying the individual parts. So, for example, we have here the statement, not both Megan and Kathy are winners. Okay. Not both Megan and Kathy are winners. The negation in the English language statement here comes before your subject, which means you want to deny the entire thing. So you would have your tilde outside the parentheses like that. So it is not the case that Megan and Kathy are winners. However, the fourth one down on the list says both Megan and Kathy are not winners. Okay, so both Megan and Kathy are not winners. Well, now the negation comes after your subject terms, which means that you have to negate them individually. So you would have tilde M and tilde K. And that is an important thing when we start looking at the translation and being able to test for whether it's valid or not, testing for the truth value of individual statements as well. Is it like this or is it like that? Because they will work out to different values. So it's important that you do the translation right. So with negation, again, the only real tricky thing with it is just to make sure that when you're looking at it, is the negation before your subject, in which case you're negating the whole thing, or is the negation after the subjects, in which case you're negating independently. Okay. Right around page 326, you'll see exercise 6.1. And basically, it just gives you a series of statements here, and it asks you to translate them into logical form, propositional form. So it starts off with very easy ones. For example, number 1 says, Cartier does not make cheap watches. Well, if we take our basic simple statement, Cartier makes cheap watches, SC, then we want to deny it, so it's very simply tilde C. And the next few are fairly simple like that, but as you go on, then they become a little bit more intense. So let's say, for example, number 7 here says, Maureen Dowd writes incisive editorials if and only if Paul Krugman does. Well, we have Maureen Dowd writes incisive editorials. I'm going to say M. Paul Krugman writes these editorials too. I'm going to use P for that. If and only if is your triple bar or your equal sign, depending on how you like it. So I would say M equals or triple bar P, and there it is. Gets a little bit more complex as you move along. So for example, number 13 says Mariah Carey sings pop and either Elton John sings rock or Diana Krall sings jazz. Well, with those, you have 3 statements that you're joining together. I'd use M for Mariah Carey, E for Elton, and D for Diana. But because there's 3 things being joined together, you have to figure out where the parentheses are going to go. So looking at the statement, it says Mariah Carey sings pop and either. When you see that either, you know either goes with or, right? And so what this tells me is that what's coming up is a disjunctive statement in its own right. Either Elton John sings rock or Diana Krall sings jazz. That's a disjunctive statement in its own right. So the parentheses is going to have to go around those. So we would have M, horseshoe, or no, the ampersand, sorry. Mariah sings pop and, yeah, so the ampersand. And then in parentheses, either Elton sings rock, E, or your wedge, Diana Krall sings jazz, D, like that. So, so it just builds in that respect. So I want to give you guys the opportunity to play with these. So the first part of your homework that'll be due Wednesday morning is at 6.1, and you can do 2 through 20 even. Since I was working on the odds, we'll let you do 2 through 20 even on those. Okay. Find where to jot that down so I don't forget. All right, 6.1, 2 through 20 even. All right. So, what you have learned in 6.1 here basically is how to translate into this symbolic logic form. So now we're going to move on to section 6.2. And 6.2 is going to introduce to us the idea of the truth table. Now this is where it gets fun. And I mean that in the sense of actual fun, not in nightmarish fun. Most people get into this and really enjoy it. What I strongly recommend is that the basic charts that I'm about to give you, write them down, keep them on a separate sheet of paper so you can make use to them as you're doing the homework, as you're doing the exams, and it's going to make things a whole lot easier for you. The truth table is basically an all worlds, all possible worlds scenario. We want to imagine what would happen in every given situation. And so we're going to play out on the truth table all of the possibilities. Now there are 5 symbols, so there are 5 basic truth tables. We start with the first one, very simple, which is negation. Okay, so I'm going to use A as my placeholder here. And to build the truth table, it's going to look like this. I have A. A can generically stand for whatever simple sentence you want it, whatever simple sentence you want it to stand for. And so negation would be the tilde A. Now, with A, there's only 2 possibilities, right? Because we follow the principle of bivalence. Every statement is either true or it is false, right? It's either true or it is false. Well, very simply, if the statement A is true and you negate it, then that makes it false. If the statement A is false and you negate it, well, then that makes it true. That's really all there is to that truth table, right? So if A is the door is open, if we're living in a world where the door is open is true, and I say the door is not open, then my statement is false. If we're living in a world where the door is currently closed, then my statement the door is open is false, so the statement the door is not open would be true. Okay, simple as that. Then, of course, next we had the conjunction. With the conjunction, you're joining 2 things together, so we're going to have A and B as our placeholders. And this means there's 4 possibilities. Incidentally, the number of sentence letters you're dealing with is going to determine the number of lines on your truth table. It goes up exponentially. So if you have one sentence letter, you're going to have 2 lines to your truth table. If you have 2 sentence letters, you're going to have 4 lines. 3 would be 8 lines. 4 would be 16. 5 would be 32, and so on. So what are the possibilities? Well, we could live in a world where A and B are both true. We could live in a world where A is true and B is false. We could live in a world where A is false and B is true. We could also live in a world where A and B are both false. Okay. So those are all the possibilities that we have available to us. So 4 possible worlds based upon the fact that we have 2 sentences. Now we're going to join those together with the conjunction A and B, which again also A dot B if you're using the book. Now think about what a conjunction is. It's saying A and B. It is saying both. So the only time that a conjunction is ever going to be true is in the first scenario. If A and B are both true, then the conjunction A and B is true. But if there is any part that is false, it makes the whole equation false. The door is open and the lights are on. If we're in a world where both of those things are true, my statement is true. But if we're in a world where the lights are not on, then my statement becomes false. If we're in a world where the door is not open, my statement becomes false. If we're in a world where the lights are not on and the door is not open, then my statement is false. So the only time a conjunction is ever going to be true is where you have that first situation, true, true, right? It becomes true. All right, so that's conjunction. Next, we have what's called disjunction. And again, with disjunction, the either or, it's going to be 2 things joined together. So our 2 placeholders here, A and B. So there's 4 possible worlds. A and B could both be true. A could be true, B could be false. A could be false, B could be true. A and B could both be false. This time it's the disjunction, one or the other, A or B. Now because it's or, either or, one or the other, the only time that it's ever going to be false is in the last situation. If A and B are both false, then the disjunction is false. But if there's any part of it that's true, it makes the disjunction itself true. Okay? So with a disjunction, the only time a disjunctive statement is ever false is when both sides of the equation have the value of false, then it's false. Any other time, it's going to be true. Then, of course, we come to the conditional. Bump, bump, bump. Everything's going along so smoothly and making so much sense, and then, of course, we always come to the conditional. Conditional also joining 2 things together, so 4 possible lines, true, 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 false, false, true, false, false. And it's if A, then B, the arrow or the horseshoe, whichever you're using. Now, we have to think about what a conditional statement says. It says if the antecedent is true, then the consequent will follow from it. The consequent must also be true. So, the example I've used before, if I release the marker, then the marker will fall, just like that. Well, so obviously in that first situation, I meet the condition of the antecedent by releasing the marker, and therefore the consequent is met by it falling. So that is true. If we were in a world where I released the marker, but instead of it falling, it floated midair, then the antecedent would be met, but the consequent wouldn't follow from it, which means that my sentence would be false. Okay. So far, so good. Now here's where it becomes a little bit confusing. The conditional statement doesn't actually say anything about what happens when the condition of the antecedent is not met. It says if the antecedent is true, the consequent must be true. But it doesn't say what happens if the antecedent is false. So even though it seems to some people like maybe we shouldn't be able to know what these values are, the fact is the propositional logic has decided that these are true. Why? Well, sticking with my same example, if I release the marker, then it falls. Suppose I don't release the marker, right? I don't meet the condition of the antecedent. I just stand here, sit here, and hold it. Well, if that's the case, then does that alter the fact that if I did release it, it would fall? No. If I released it, it would still fall, right? But I'm choosing not to release it. I'm not meeting the condition of the antecedent. But if I did, the result would still happen. And that's why they consider it to be true. But again, the important thing for us to remember here is that with the conditional statement, the only time that a conditional is ever going to be false is when the antecedent is true and the consequent is false. In that possible world, the conditional statement is false. Any other time, it's going to be true. And so finally, we come to the biconditional. Again, joining two things together. So 4 possible worlds, true, 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 false, false, true, and false, false. A equals or triple bar B. Now, the reason why I like the equal sign is because it reminds you basically that A and B in a biconditional should have the same value. And so, very simply, if they have the same truth value, the statement is going to be true. So in this first world, A and B are both true, so the biconditional is true. In the last situation, they have the same truth value. They're both false, so that makes it true. If they have the same truth value, they're true. If they have opposite truth values, then they're false. So in the second one, A is true, B is false, that's false. In here, A is false, B is true, that's false. Okay, so biconditional is, you'll have these written out in front of you to use, but it's pretty easy to remember if you think about it in terms of that equal sign. Same value, true, opposite values, false for the biconditional. Okay. Now, once you have those 5 truth tables, those are the tools that you're going to be using for both determining the truth value of sentences and for determining the validity of arguments. So, let's take a look at using these for sentences to begin with. And let's just say for simplicity's sake here that A and B will always be true, and C and D will always be false. Okay, this is only for what I'm doing here. Don't use this when you're doing homework or something like that. They'll tell you their own rules or give you their own information there. But for the purposes of explanation on the board here, A and B should be considered true, C and D should be considered false. All right, so let's just take a couple simple statements here. Okay. So the first one, we have A and C. Well, I've been told that A is true, and I've been told that C is false. The symbol that's being used here is the ampersand. So I'm going to look on the conjunction chart, find the line where the first letter is true and the second letter is false. True, false with the ampersand gives me a value of false. Right? Because remember, with the conjunction, the ampersand, the only time it's ever true is when both sides of the equation are true. If any part of it's false, it makes the whole thing false. Number 2, we've got if B, then not D. So we're told here that B is true. We're told that D is false. But now you'll notice that that D has a tilde in front of it. So using your negation chart, if your letter is false and you negate it, what happens? Well, it becomes true. Right? And so now we look and we see that our antecedent is true and our consequent is true. And we look on the conditional chart and we find the line where the antecedent is true and the consequent is false. Is true. So true, true with the arrow, or true, true with the horseshoe if you're using, works out as being true. Okay, so these are pretty easy, pretty fun. But let's look at a couple more that get a little bigger. So let's see, number 3. Let's do one that has parentheses in it. So how about A, if and only if, C, or B? All right, so in this case, we have A is true, C is false, B is true, right? And we know that because that's what I've given you up here. Now this is where that order of operations comes into play. You always start, if you have parentheses, solving what's in the parentheses first. So we've got C or B. The C is false, the B is true with the wedge. So you're going to look at your disjunction chart, find the line on that disjunction chart where the first letter is false and the second letter is true. False, true with the wedge gives you true, right? Because again, remember, with disjunction, the only time it's ever going to be false is when both sides are false. Any true element is going to make it true. Well, now we see the first part here worked out as being true. The second part worked out as being true. True, true with the triple bar or with the equal sign. If you look on your biconditional chart, you'll see true, true yields a value of true for that sentence. Again, if the first and second, if they share the same truth value, either true or false, then it's true. If they have opposite values, then it would be false. Okay. Let's do another one, maybe a little bit bigger here. How about not A and not C, then B or D. Okay. All right, so here we can see not A and not C, then B or D. So A, we're told, is true, C is false, B is true, D is false. We've got two sets of parentheses. We'll start here with the first set. Inside the parentheses, A and not C. Well, C is false, but there's a tilde in front of that C. So the false becomes true because of that tilde. Now we have to look at our conjunction chart. True, true with the ampersand is going to give us true. So everything inside the parentheses works out as being true. But notice there's a tilde in front of that set of parentheses. So that means that the total value you've now figured, which is true, has to be negated. which makes it false. Second set of parentheses, B or D. B is true, D is false. True, false with the wedge, look on your chart there for disjunction, and true, false gives you true. So now we've got the arrow or the horseshoe, which is the conditional. So we know the antecedent works out as being false. The consequent works out as being true. False, true with a conditional is going to be true. Because again, the only time a conditional is ever false is when the antecedent is true and the consequent is false. If the antecedent is false, the conditional is always going to be true. Okay. And let me do one more larger one with you here just for the fun of it. Let's see. All right, so here's a really big one. If you can do this, you can do anything that we've got coming at you in this whole chapter here. It shouldn't be that difficult. So now we've got one that uses parentheses, brackets, and braces. Big ugly thing, I have no idea what it could actually mean, but we can still solve it in terms of its truth value. So we're going to start the same way we did before. We've got A is true, B is true, D is false, D is false, A is true. So we always start inside the parentheses. Inside this set of parentheses, we have B and D. B is true, D is false. Using the ampersand, the conjunction chart, true, false with the ampersand is going to be false, right? Because again, the only time conjunction is ever true is when both sides are true. If we look at this set of parentheses over here, you'll notice that there's a tilde in front of that D. So if D is false and we negate it, it becomes true. And there's a tilde in front of the A. So if the A is true and we negate it, it becomes false. So not D is true, not A is false. True, false with the wedge. You look on your chart there, and true, false with the wedge would give you true. Because again, the only time that the wedge is ever going to give you a false statement is if both sides were false. Any part being true is going to make the whole thing true. All right. So we've done parentheses. Next we go on to the bracket. So here we see A as being true, and we've worked out that B and D is false. So true, false with the wedge is again going to be true, right? Because again, it's a wedge. All it takes is one side to be true to make it true. So now we don't have another bracket. What we do have is a brace. We're going to go on and we're going to look at the brace now. And we'll see that inside of the brace that A or B and D is worked out as being true. Not D or not A is worked out as being true, and there's the equal sign or the triple bar, depending on which one you use, which is there. And so looking at your biconditional chart, if the one side is true, the other side is true, they have the same truth value, true, true, with the triple bar yields true. But one last thing. There is a negation sign outside of the bracket, which means that the entire value of what you've just discovered right here as true has to be negated. So that true becomes false. Okay? So again, these are kind of fun when you get into it, pretty easy to work with. And hopefully you guys catch on to it pretty quickly. Most people do. no matter how long an equation gets, you're still never looking at more than two things at a time. So just take it step by step by step, and you'll be able to get there without any difficulties. All right. On or around page 340, you will see exercise 6.2, section 3. It says, determine the truth values of the following symbolized statements. Let A, B, and C be true, and X, Y, and Z be false. Circle your answer. So it starts, the first one is A dot X, and then B dot not Y, X wedge not Y. So hopefully everybody sees the right one that you're at here. But I'm going to let you guys play with these. So this will be the next part of your homework for that's due on Wednesday. So we'll have at 6.2, section 3, 1 through 25 odd. Okay, so I want to give you a good amount of practice on this because it's actually pretty important. So 1 through 25 odd on that. Just determining what the truth value is of those individual statements. And again, pay attention to the instructions that are given there. For this purpose, A, B, and C are true, X, Y, and Z are false. But then just use the truth tables to figure out the truth values from there. Okay. Section 6.3 doesn't really have a whole lot that is of relevance to us, but there is one bit of terminology that I want to share with you, and that deals with different types of statements. We have what's called a tautology, and a tautology is a sentence that is always true. So if you were to work out a truth table for it, every line would be true. We have what's called a self-contradictory statement. And with a self-contradictory statement, every line works out as being false. So a self-contradictory is always false. And then the third type of statement, which is what most of our statements are called contingent. And contingent statements will have a mix of true and false. Okay, so just a matter of simple terminology for us. If you have a statement where every single line is true, that's a tautology. If you have a statement where every single line works out as being false, that's called a self-contradictory statement. And if you have an argument where there's a mixture of true and false statements, then that is called a contingent statement. And again, the contingent is what most of our statements are going to be. I'm going to give you a couple simple examples here, though. Suppose that I were to create a truth table. I'm just going to use a simple one here, the single letter A. So A could be true or A could be false. Suppose I wanted to say A and not A. Oops. Okay, A and not A. Well, on the first line, right, A is true. There's a tilde there, so the true becomes false. True, false with the ampersand is going to be false. On the next line, A is false. So A is false, A is false. Negate the false there, false becomes true. False, true with the ampersand is false. So even though it's a simple example, you can see that the statement A and not A is a self-contradictory because every line on the truth table works out as being false. And suppose we take another one here. We'll build a simple truth table for A or not A. Okay? A or not A. So on line 1, A is true. There's a negation there, so the true becomes false. True, false with the wedge is true. On line 2, A is false. A is false. The tilde there makes the false true. False true with the wedge works out as being true. So again, even though it's a simple example, you can see that every line on the truth table works out as being true, which means that is an example of a tautology. Okay, so that's all you really need from 6.3 is just to understand the terminology there. Tautology, every line is true. Self-contradictory, every line is false. Contingent is going to be a mixture of true or false. Okay. So I'm going to break this up into 2 videos. So I'm going to stop at this point because you may want to practice with the stuff that we just talked about before you move on to attempting to do the work with arguments. So I will be back in the second video for that purpose.